So, welcome everyone to this early Saturday session. So, first of all, let me introduce myself. I'm Victor Zhestkov. I'm working in SUSE since the beginning of 2006. And originally I joined as a supporter and sales engineer. And then I switched the role, and the switch was kind of related to the topic of this talk. And to give some of the background, probably it could be important in this case. We had the customer, really big one, with the kind of challenges with the our downstream project, which was called SUSE Manager. But all of the parts of this topic are related fully to the Uyuni, and so in the context of the Uyuni. First of all, let me explain what is the Saline. So it was started in 2020 as the kind of POC project for the only one particular customer with the huge challenges on using salt. And this POC was prepared during the COVID lockdown as a kind of, let's say, funny naming of this project. Is Saline is the mix. One of the meaning of the word is the mix of the salt and the water, just to make the salt not so challenging to be eaten in the raw form, let's say, as it's not so delicious in this form, in the raw. So originally the project was intended to be used as a flexible way to managing state apply process for the large amount of the minions. In the case of targeting of few thousand of the minions, the customers could get some common challenges, especially in the way of the let's say ease of use from the web UI. And this project originally, I mean, the Saline itself was released with Uyuni 2024-12, so last year, close to the holidays, and it will also be released as the part of SUSE Multi-Linux Manager 5.1 quite soon. And for now, as I said, the original idea was the project was quite broad and deeper than what we have right now. We decided to reduce the, let's say, scope of the features provided by the Saline, and for now it provides just the metrics exporter for the parameters. And you can see the URL for the project, and it was moved under the umbrella of openSUSE this year. And for now, we are releasing just the container for SUSE Multi-Linux Manager and Uyuni, and it's not yet available as the standalone package, but in general, it can be easily used from the projects of Uyuni. And to give some background, what we had before the start in this project, we had the Grafana with the monitoring server, with the set of dashboards, where we can expose the metrics from the running server itself, and we can see the workloads on the memory and the CPU as well. And one of the problems and the complaints from the customers that it's not that clear what this Saltmaster is doing on the server side under the hood. You can, for example, try to use any of these ways to get additional data from the Salt event bus to understand what exactly is performed under the hood, what actions are triggered by master itself, what are the responses from the minions. But one of the challenges you will get with trying to use any of these ways, you will see something like this, most probably. And this recorded video represents the kind of corner cases when there is a kind of authentication event storm, as we called it, when the huge amount of the minions are trying to authenticate again and again to the master. As due to probably the connection issues, some of the timeouts, etc., and by the default, SUSE, Salt minions are quite aggressive with their authentications. And on the next recording, you can see the slightly different picture. You can see that the events are bit different. The set of them is different. They are still visible, the authentication terms, but there are some other events which are really challenging to, to be read on the raw form in this case. And with this particular customer, as I mentioned, we captured this event-based data for around 12 gigabytes. And it was the starting point of developing my project. So, and on this shot, you can see the result of state apply. And as you can see, it's quite easy to understand what's going on there. So, very easy. And as the customer has a valid complaint that it's not that easy to figure out what's going on in the scope of the large amount of the minions, and especially when you're trying to trigger the state apply for even 1,000, or in their case, they had 38,000 minions. So, what challenges do we have? Do we have enough information from the saltmaster to figure out what's going on under the hood? Probably not. And what are the calls in the saltmaster causing the most workload for the server itself? So you can see that the spikes on the CPU usage and as well as the memory. You see the huge amount of the incoming events from the minions, some of the responses from the master, and it's not really easy to align which of them are really causing the huge workload. And particularly for the state apply, it's not yet clear for the large scope what is the coverage of the, let's say, successful state applies and the failed ones, and what failed state applies are actually failing on. So, and it's not that clear the overall state of the saltmaster itself, as it's not that visible if it's in the idle state or either performing some actions and triggering some events from the minions, etc. So in most cases, it's not so easy to figure out. And the other point, I think the last one, is that in some cases it could be interesting to know if the behavior of the server has changed somehow due to the maybe external conditions or due to some unusual use cases from the state apply process or the unusual calls from from some particular minions, which could become, as I said, quite aggressive on the authentication. And yeah, so we are providing some of the panels. I will show you probably better in the live monitoring server. But first of all, I will show you how easy to figure out what's going on for the one particular system. So we need to click on the system, go to the events, and check the history. And you can easily find out the results of any of the actions performed with the system. So we can figure out the state apply with the high state, and we see that something has changed. But you can imagine that how easy this process could be on the, let's say, even 100 systems. But in the case of this particular customer, we had, as I said, 38 K minions. So not that easy to figure out. And finally, we provided the such solution as Saline with the set of the metrics. On the first chart, you can see the overall amount of the salt events with the spread divided by the event types to, let's say, in the more human readable form to understand what's going on. And you can check the certain events on the time frame. And in this particular demo, I'm just playing back some of the pre-recorded events back to the salt event bus to make them consumed by Saline. And on the next chart, we can see the representation of the overall availability of the minions. They are spread by the activity for some interval of times, like 1 minute, 5 minutes, 15 minutes, 1 hour, active ever. So active ever actually means that if the Saline ever seen any activity of the minion, it just calculates all of the such active minions. And the offline means actually that some of the minions are not responding in some interval of time. They defined as the offline due to the inactivity. And other probably interesting, the point with the scene, which is not that clear from the naming, but maybe we need to figure out the better naming for this. But it actually means that this minion was, this particular minion, was ever seen in the other request or the response. So in the summary of this scene, you can identify the, let's say, maximum amount of the minions. The next chart representing, let's say, more detailed form of this first one, this one, but with the no assigning the particular human readable, let's say, event type. In this case, it represents only the tag mask and the function called, and as you can see, it is divided to the negative and positive side. On the positive side, we have the request from the master to the minions, and on the negative side, we have the responses from the minions. And in most cases, they are matching only in case of triggering the action for the one particular target. But in case if you call, for example, state does ping for all of the minions, you will get the only one event on the positive side and the huge amount of the responses on the negative side. So this chart become, let's say, kind of unbalanced in this case. And the second chart is representing the exactly the state applied process, and it presents the divides the state applied by the but success state. So some of them are successful, some of them failed, and you can see the amount of these fails. But unfortunately, on this particular form, you can see the reason of these fails, and in some cases, it's also could show the some errors happened on the site. So basically, salt state errors in this case mean that the state wasn't failed, but most probably the exception happened during the state apply. So it's something to figure out on the minion side, what's going on there. And next two charts represents the salt master internal statistics. These statistics should be enabled with the additional tweaking parameters master starts true, and you can assign the interval of publishing these statistics from the workers. And the most interesting point regarding these two charts that it's better to analyze them in combination of both of them, as the not just only amount of these calls is important, but also the duration, average duration of the each call is important here. So in general, right now we are fighting with the performance on attempting to reduce the number of the useless calls performed to the master, and the reduction, the average duration of these calls to avoid the master getting stuck on some specific calls. And as I said, you can see the really huge amount of the some specific events here. As the kind of practice, let me describe you one point, that we have this file find and file hash calls, which are kind of almost identical here. And the funny thing that this file find call is totally useless in case of the minion and the master, and it was introduced long time ago, but then the call was removed from the handling the data of this call on the minion side. So the minion keep trying to call this function, but not using the results of this function. So it's totally useless, and especially in the context of the huge amount of these calls. This call was removed due to the CV, and it was a kind of leftover on the upstream side. So we already, I think, agreed on removing this on the from the minion, and we will get the huge improvement of the speed on the master side as well. But the most challenging part here that to fix it, we need to update all of the minions to avoid these calls. So, and as I said, the other important point is the duration of the average duration of the call. And in this case, I will point your attention to the call on this particular customer. We have the issue with the pillar call. It was improved significantly. Originally, this line was on the level of about 4 seconds, and then we dropped this duration significantly, even less than 1 second, which is quite high value anyway, and we need to dig even more to figure out what can be improved under the hood for the pillar rendering in this case. And the other important point, you can see the very high line on almost on the 10 seconds. It's the wheel call, and this particular call is related in this case to the listing of the salt keys from the master. So when you're trying to reach the web UI, the page called salt keys, it's exactly the call performed to the master to get this data. And in case of having a large amount of the minions, these calls performed with no any caching, just to ensure that you getting the fresh data from the master, and you can easily catch the new authenticated minions to either accept them or reject. And as I mentioned, there is no any caching, and in some cases it takes quite significant time. But for this particular customer, we already reduced the number more than twice, but they haven't yet tested this fix for some reason. And let me switch back to the presentation, and I will show you some more. This one I already show you. So, and as I mentioned, for the master statistics, we need to add extra tweaks to the master configuration with adding master starts to true, and you can adjust the master starts event iteration. So it actually applies to the interval of the publishing these statistics. Don't be afraid to enable it just because it doesn't affect the performance of the master, but this statistic could be really important in case of trying to improve the performance on the salt master side. And we also provide a few more panels. One of them is the job state, salt state jobs. As it says, it's the instant, and actually it uses the data only from the exporter, not using any actually stored data, and showing just the only running process currently. So it presents the overall state of the state apply. You can see the number of targeted minions, the progress of the appliement. So if the process haven't finished yet, so you will see the progress is not on the 100% level. So, and you can see the other statuses, even if the state was failed or not. And we also have this salt state profiling panel, which provides deeper, let's say, profiling information. You can identify the parts of the state which takes most of the time, or most of the time consuming part, let's say, on the state apply process on the minion side in this case. So you can use this data to optimize your states. And some of the Saline in real use cases. So this data was captured from one of the real customers, and with the state profiling on the left side on the bottom, you can see the quite significant durations of the state apply for the some particular test states, and in most cases this PKG installed calls causing such high duration due to the refresh performed for the refreshing the metadata from the repositories. And on the right side, we can see the state apply process in live manner. So we can see that there are significant amount of the failed states for the first wishes manager. One uploaded something. And the next one, I just mentioned this issue with the rendering pillar data. I will show some of the internal details of the improvement this particular issue with the rendering on the master side, and also some of the optimizations on the code side. So the issue was actually not just, the issue was not just actually on the, let's say, code side, but also the exact pillar tweaks this particular customer has on the environment. And one of the issues with the code was that they are using matcher for the pillar data, and in case of using the huge list of these matchers, the Salt Master internally with the lazy loader reloads all of the matchers every time it sees the new matcher in the rules, and it was actually unintentional, and we improved this significantly, and this call dropped to almost about 1 second. And what's next? About the idea itself, I think it's quite similar to what we have in the automotive industry with the cars. And if you have ever tried to use some diagnostics devices for your car to figure out what's wrong with the engine, etc., it's kind of similar in this case. So in our case, the Salt Master is the engine, and we are trying to do some tweaks and understand what's going on under the hood and what happened during the work interval of times, especially in some cycles during the week, maybe a month, a day. And the idea with the profiling from our side, with some code optimization, is to avoid such cases with the engines on the road. So we want to avoid it and trying to use some of the internal, let's say, tools to synthetically cause the huge workload on the master, just to prevent this from happening on the highway. And one more interesting example. So last, I think, couple months, we were fighting with one of the issues related to M2 crypto particularly, and to be exact, not just the M2 crypto library itself, but the combination of M2 crypto and the particular openSSL it was compiled against on the system. And this chart represents the different results of the different test cases. You can see the on the first line, the average duration of the authentication call for one particular minion, and this duration is too high and almost 50 times higher than usual we saw before. And we narrow down this issue with the kind of not the incompatibility, but the as openSSL 3 mentioned, that it could be some cases when, in comparison to openSSL 1.1.1, it could become too slow in some certain cases, and these cases should be fixed either on the code side or in the way of using some of the calls. So after implementing some of the fixes for M2 crypto, we we were able to drop this duration significantly. So you can see the second and the third test, which is actually what we have right now, and this fix was already released. And on the third place, there was an attempt to fix it just to build against openSSL of the previous version, and it didn't give us such benefit anyway. So we decided to stay with the openSSL 3 as it's more secure, and just to implement this fix for all of the affected versions we had on that moment. And on this slide, I can show you the list of the particular fixes we promoted for the upstream of Salt, and some of them are only relevant for our branch in openSUSE Salt. As you can see, actually this slide was taken on the maybe February, and most of these fixes already merged and promoted and are in place. The most interesting one, I would say, the second one, about the login itself. We provided the fix to make login of the Salt master way lighter than it was before. So in case of enabling the debug or trace login, you could get some issues just because the too high login level set and the Salt master becoming too slow just because of the high login level. And I think for the fixes, maybe, as I already mentioned, this file found issue, which is not really relevant anymore, it was removed. And with the batch async improvements, these improvements only make sense for our openSUSE branch, as batch async implementation not yet approved by the upstream. And about some of the recommendations for the Salt minions. With this amount of the minions, first of all, we need to think about to make them less aggressive on re-authenticating. So it's one of the recommendations for the set of the parameters for the minions. So the next recommendations are for the Salt master, and the important ones, I would say the first two, they are actually hiding the not really relevant events to be published with the event publisher. They are just will be hiding in this case. In context of Uyuni, they are not used at all. But in case if the customer for some reason are using this salt auth tags with the events for any reason, they should keep it enabled. So the next point is the connection cache. It was a kind of a found feature in upstream. It was implemented about I think more than 10 years ago, and for some reason it's now broken and not really providing any benefit. But in case if you enable it, you most probably will constantly producing zombies with the Salt master. So it will produce zombie, I think, almost each second and kill the previous one. So kind of the mess with the implementation internally. And the latest suggestion is makes sense only mostly for the Uyuni customers with the large scale to avoid triggering batch async in case if it's not really necessary. For example, the batch async in general makes sense only if the large amount of the minions targeted, and we are asynchronously calling this function on the minions with some certain number of the batches. But in case if we are triggering the event only just, for example, 5 minions, it doesn't make any sense to call the batch async with the number of batch equal to 100 or 200 as default. So in this case, this parameter could help to reduce these useless batch async calls. And as I said, these master stars, it's highly recommended to be enabled to get the extra benefits from the charts provided by Saline. And the rotation is key is kind of not really recommended solution, but in some cases with the large deployments, it could be necessary, but the customer should take care themselves on the security, let's say, side of this point, as in case of setting this parameter to false, the master will not push the minions to re-authenticate. And if you haven't stopped the minion which you are going to delete, it will continue reading the events from the master. So it will continue. If it could still be able to get some data from the master and react on it, and maybe call some of the file synchronization functions, etc. So in this case, it's recommended for the customer to take care themselves to first stop the minion, and then it's done. Just because on the next attempt to restart the minion, there will not be any availability of authenticate for this minion. But it really helps to avoid this authentication storm when the minions have to re-authenticate again and again. And the latest one is the really important recommendation about the number of worker threads set for the master. In some cases, the customers could assume that it's a good idea to put as high value as possible, and they could put some 100 or even some cases 1,000 maybe threads, and actually this parameter is not really reflecting the reality. It doesn't mean the threads, but the sub-processes of the salt master workers. And in case of setting them for the value higher than the number of the cores available for the server, it will cause the kind of competition between the salt workers, and they are starting to fight to each other for the resources instead of the performing the really useful calls. And as I said before, there are some recommendations for the master on the, let's say, tweaks side from the customers. First recommendation is to avoid using reactors, especially in case of reacting on really frequent events from the minions. In this case, it's really better to write your own engine or even standalone service to read the salt event bus and react on these events on this level instead of letting the reactors do their job. But the implementation is not really great there for the huge amount of the calls which could be handled. And with the any custom model customer or the supporter trying to provide for the customer, it's important to do a proper exception handling. With no proper exception handling, it could be the case that the exception could go to the salt code, and one of the workers could be crashed or reacting not really properly on this exception on the level of the extension model, custom extension model in this case. And I mentioned the issues with the pillar rendering. So the example from the customer was the top SLS file with this rule, which is actually matching the grain for the particular value, and the number of such rules was really enormous and more than 1,000. And in case of having the issue before with the reloading the matches with the laser loader again and again, we get quite high numbers on the average durations of these calls for the pillars. We improved this significantly on the code side, but still, if the customer trying to use this way of customization, it could be problematic. So it's recommended to rewrite this list of the matches to the kind of more trickier code. It's a bit more complex, but actually it does the same job as the list of the matches in this case. But we are only providing the kind of mapping and selecting the proper value on base of the value of the grain. So the same idea, but it works more than twice faster. And I think that's it from my side, and you're welcome to ask any questions. Don't be shy, and you're welcome to any questions.
Hi, thank you for your talk and also the nice recommendations for the Salt Minion and Salt Master. I have the experience that with some exotic slow hardware, sometimes they take very long to respond. I didn't see recommendation for increasing the general timeout, and we are even running something like 2 minutes. It's 5 seconds by default, right?
Yes, by default it's 5 seconds, and it could be tweaked in some certain cases. And the trickiest point here that I don't think there could be any common recommendation for all of the customers, just because the really different use cases and really different let's say approaches of using it, and different landscapes and the deployment environments. Let's say we have some reports from the cloud users about some network issues possible. One of the latest one, I remember that in case of using some certain types of the instances, the storage is too slow on the minion side, and in case of calling some of the functions from the master to the minions, it's responding really slow, and in some cases it could be defined by the master as offline. So in this particular case, it's better first of all to figure out the exact reason of this long response from the master side or from the minion side. And in case if the hardware is really slow, then it makes sense to play with the timeout values on the minion side. Yeah, it's true.
Yeah, thank you.
Hi, I got no question, but I just want to say thank you, because we have some customers that really have problems in gaining knowledge about what their Salt Master is doing, and they also use Grafana and the salt stack formulas for monitoring, and this helps a lot. So thanks a lot for showcasing this.
You're welcome, and I would suggest, I think, to play with the ways of representing this data, just because it could be not really useful for most of the customers. It's just my suggestion, how can I get the additional data, and how can it be useful for me in my case. So, but for the customer, they could decide that they could have the different ways of presenting it. And maybe I forget to mention some of the points regarding the one of the charts. You can see on this chart the some of the marks on the negative side. It's the actually individual actions which could be important in some cases. So in this case, important not the amount of such calls, but just the presence of the such calls. So, and I haven't found any other proper way to represent them on the chart. So if you found any, so you're welcome, and feel free to contribute and
Thanks a lot.
Then, thank you. Have a nice day.